Hello, everyone. My name is Kazem Kookaram. Uh, I'm a science journalist and also a member of editorial board of Nujum magazine in Iran, uh, and also a member of Iran Messier Marathon organizing team in last 2 decades. Today, I want to tell the story of something that started as a simple observational competition, but gradually uh, became a tool for astronomy communication, community building, astrotourism, dark sky awareness, uh, and also redefine the people's relationship with the night sky in Iran. Uh, it's the story of Iran Messier Marathon, but it's not simply the story of a competition. It's, uh, it's the story of localizing a global idea to meet the real needs of our society. Next slide, please. Yeah. How can I go to next? Yes. Let me begin with with the night in the spring of 1999. Around 40 amateur astronomers from every part of Iran gathered in Qasr Bahram Karvansaray in an ancient building in Kabir National Park to observing the night sky. All Messier objects, 110 objects in one night in the fourth marathon. On that night, access to the internet was difficult. The social media didn't exist. Access to the telescope was also difficult. And Iran Amateur Astronomy Society was very still small. But on that night, something happened. Uh, Observing the sky changed from an isolated activity to a collective experience. On the other hand, we didn't only observe the sky, observe the galaxies and nebula. We built a community. Uh, Next, please. Within 2 decades, the Iran's Messier Marathon became Iran's largest astronomy gathering. Uh, as you see in this map from every part of Iran, some participants traveled more than 1,000 kilometers to be one night under the dark sky in the Messier Marathon. The question is, why the Messier Marathon? Why this competition became so influential? The answer is because the Messier Marathon in Iran was not uh, was not only a competition. It became a platform for education, social networking, shared experiences, media storytelling, and creating a cultural identity around amateur astronomy for every amateur astronomers in Iran. Also, you can see in the diagram the number of participants that year by year is increased. Also in the era of COVID-19, it's cancer. Also in 2009 election protests, we cannot hold the Messier Marathon in Iran. And also in last March, because of the war, we cannot hold the Messier Marathon. Next, please. One important lesson we learned was this. If you want to survive a scientific event, you must localize it. So the classic form of Messier Marathon was not enough for our society. Because, for example, some of enthusiasts they didn't own their telescopes. Not everyone had observing skills, advanced observing skills. March weather in Iran is often cloudy, and younger generation wanted more visual and social experience. So decided to redesign the marathon message according to all local needs in Iran. That's become the turning point. Next, please. In 2008, we introduced the educational section. It's one of the most successful innovation in the Messier Marathon in Iran. One of our most successful in Messier Marathon in Iran because the beginners, the students, the families, all of them joined us in the event and learned the telescope observing with experienced instructors. The idea worked surprisingly well. Then after a few years, the number of participants, the participation in the educational section exceeded the participation in competition form. Uh, it seems that the Messier Marathon is going to something closer to be a public astronomy festival in Iran. Next, please. As astrophotography became popular in Iran, we noticed that the younger generation experienced the night sky through the camera as much as through the telescopes. So we added the third section, astrophotography. This attract photographers and also the artists into astronomy community. Also transform the night sky images, transfer the night sky images into a powerful communication tool. So astronomy become part of visual culture. Next, please. Iran Messier Marathon also evolved technologically. Judging process in the Messier Marathon relied on paper form and also manually confirmation. So we added some people, some persons as an assistant for the judging during the Messier Marathon, but it's not enough. So we are going to design a website, an online scoring system connected with the application, iOS and Android application, to submit the observation during the competition. And also we deployed a red light scoreboard that preserved the night visions of observers in the night. Also, as the Messier Marathon, as participants became more skilled, the observing of all Messier objects became more common. So we added more challenging objects from the NGC IC calendar and Melot catalogs to the Messier Marathon. This transformed the event to a serious observational challenge. Next, please. But our success was not the competition itself. It was media storytelling. From the beginning, we involved television, newspapers, magazine, and later social media. For example, you see that the interview with the participant in the governmental television in Iran, Khabar channel, Channel 4, the TV show, Night Sky TV show, and also next, please. Full coverage of Messier Marathon in news agencies, and next, please, and also in the newspapers, and also Jamejam newspapers in cover page, and also one full page with introducing the winners of the Messier Marathon. So as we became part of the public conversation, you know, also in Nujum magazine, Danestaniya magazine, all of the popular science magazine covered this competition. Next, please. The popularity of Messier Marathon also inspired the Iranian movie, So Close, So Far. It's a famous Iranian movie. More than half of Iranian people watched this film, and this shows an important thing. An astronomy event had entered a popular culture. Next, please. An unexpected outcome of the was social, was impact on regions hosting the Messier Marathon gradually became for dark sky awareness. So ecology appears. Astrotourism developed, and people realized that preserving the dark sky could also create economic value for them. Next, please. Later, then we designed the Sufi observing competition, named after the Abdurrahman Sufi. It connected modern society with the 1,000-year-old scientific heritage. Abdurrahman Sufi is a Persian astronomer who observed some of the deepest objects by the naked eye around 1,000 years ago. for example, Andromeda Galaxy, and we put these objects that he mentioned them in Book of Fixed Stars on the Sufi observing competition. Once again, the media storytelling had an important role, and also people rediscovered an important part of their historical, of the astronomical history. Next, please. It's the last, I think. 4 lessons we learned. 1, astronomical competitions can become powerful communication tool. Number 2, localization matter more than imputation. Number 3, media are part of the project. And number 4, astronomy can build communities. These are the winners of last Messier Marathon in Iran. Next, please. Today, after more than 2 decades, still hundreds of people still gather in under the dark sky in every year. I think our most achievement is not creating a skilled observer. Our most achievement is reminding people that the night sky can still bring people together. Under a world, even a world filled with screens, city lights, and social distances. I hope we can welcome some of you in Iran Messier Marathon soon after finishing the war and spreading the peace in our region. Thank you very much. What? Thank you very much.
Thank you. Is there any questions in the room? We have space maybe for one question.
So great achievement. I congratulate you. So just to make clear, all the telescopes are manual, right? There's no go-to telescope.
We didn't allow them to use it. The judge check it minute by minute that they don't use the robotics, the telescope. And judging process in Iran Messier Marathon is really serious, and hopefully we can make a Messier Marathon in our region. For example, with participants, some amateur astronomers from Turkey, from Pakistan, from India, from Arab countries, as a regional marathon, Messier Marathon. I think our experience could help this. Also experiences in other countries, other neighbor countries, I think.
Okay, thank you. So our next speaker is Mohammad Abbas. From the UAE, and he will speak about From Heritage to Horizons, Astronomy Outreach in the Middle East.
Thank you. Okay, hello everyone, and thank you for this opportunity. So I've actually changed the topic of the presentation a little bit after taking an approval. So I'll be speaking more about our center, which is called CAS. CAS is the Center for Astrophysics and Space Science at New York University, Abu Dhabi. I know it's a long title, but this is how it is. So today I'm going to tell you a bit about what we do in terms of outreach. So maybe we can exchange ideas, you can take some ideas, you can propose new ideas that we can add to our program. So it's really going to be about what we do. There are 4 main people working on the outreach program. That would be Bianca Arkin. Probably you've seen her name. She's the outreach manager. She was supposed to come here, she couldn't, but everything is done with Bianca and Andrea Macho. myself, and Fahad Rizwan. And myself, I am actually a researcher. I work on the Milky Way formation history. Our center is a big center. It has around 40 people of researchers, mainly researchers, postdocs, faculty members, PhD students, and we do different type of research, which I'm not gonna cover today. This is a group picture of most of our group members, and this is in our campus in Abu Dhabi. This is more images from our campus, just to give you a feeling about our campus, because probably none of you have been there. Maybe one person I know has been there, which is Nick. Okay, so this is more about NYU AD, and if you ever go to that part of the world, please let me know, get in touch. We do a lot of conferences also, and this is one of the images from our conferences. This is some of our, again, pictures from our space. So what we do in terms of outreach, we do a lot. I'm gonna go over them really quickly, okay, so you get as much information as possible. We do high school astronomy seminars, and we really try to adopt whatever Einstein, well, they say Einstein said that, but I'm not sure if he really did, because it's unsure whether he said it or not. But the point is, we try to simplify things as much as possible. I mean, even when you talk about things like string theory, how can you simplify string theory and deliver it to high school students, for example? And to give you an example, these are some of the high school things we do. We actually do, I don't want, it's not experiments, but I would call them on-stage demonstrations. It could tackle topics in time travel, in gravity. You all are aware about the gravity well, about the string theory, Minkowski space-time, if you're aware about that. So there's so many things that you can actually do on stage as demonstration. It takes a lot of work, a lot of preparation, but really the results is usually is very fruitful. Other things that we do is we also do stargazing, moon gazing, and solar gazing. We do a lot of them. For example, in the last eclipse that happened, we were trying to do something from campus, although it wasn't a total eclipse. We do a lot of trips to the desert. We do a lot of lunar gazing from campus, off campus. So we keep ourselves busy in small projects and also in big projects. This is also, sure. This is also something that we did at the Louvre Museum. So there is a Louvre Museum in Abu Dhabi. So there was one day dedicated for, astronomy in addition to other activities. And we took it over, we put some telescopes, and you can see here this little kid who happens to be my son observing the sun from the Louvre Museum. We also organize a lot of students and public visits. We get students from all over the Emirates in the UAE. We tell them about what we do, about our center. We encourage them up to pursue careers in science, or maybe we just give them the knowledge about science or astronomy. We do Lego nights. We gather kids, and some people really love Legos. Maybe some of you are also Lego lovers. We gather people once every month or so, and we get them sets, and they could assemble all these Legos. We do pop-up demonstrations or exhibitions, small ones really, to demonstrate our research. Remember, our center is more research focused, but we're also really working hard on the outreach program. This is a cosmic ray detector. If you go through these things, you will really see really cool stuff. One very cool item, one of the group members, Dimitra Atri, working on is actually somewhere here, is the moon simulant. So what he's actually doing is he's working on moon dust here on Earth, trying to take advantage of it that could later on be used on the moon. And this is real research that is happening in collaboration with the UAE Space Agency and other UAE and other space agencies. Of course, the typical legendary movie Interstellar. We have a movie theater, so we also gather students and do after discussions and also demonstrations. So these are I want to say these are the little small pop-ups events that we do regularly, more than once a month, give or take. We also do a lot of collaborations with different universities, not only in the UAE, but also in the region, in Saudi Arabia and Oman. We try to really connect with different entities in the region and also outside the Middle East. We try also, we get a lot of news coverage, articles. Here just a screenshot of different articles. And this is something that regularly happens. again, because we have many researchers publishing some really interesting work. And we also get coverage for our outreach program, and this could be one of the examples. This is something that we have also worked on. It's not photoshopped, it's not AI, it's actually a CubeSat that we have sent to the ISS in collaboration with other entities in the University of Malta. There's an experiment inside which I don't want to go over now, but you can, I mean, the image itself, it speaks by itself, right? This is in the ISS. And this is, we've printed this on a big poster and we put it in our desk offices. So other than this, we do once a year, we do astronomy camps. You're all familiar with this. Every year we change the theme of the camp. We stick to the regular, it's like a crashed introduction to astronomy course, like an astronomy 200 class given to undergrad students. But each year we get special topics and we get special speakers discussing different topics. So this is how it would look like. Usually it's 4 day long, 3 days sessions, and then the fourth day would be a visit or going somewhere or seeing, you know, hands-on experience anyway. So this is how we do our camps. There's also a certificate. We give them certificates. This is one of our groups of students that graduated in one of our camps. We also do astrophotography workshops. We do a lot of the, well, once a year, but what we do is we invite one astrophotographer from somewhere in the world. We try to stick to the Middle Eastern astrophotographer, one new astrophotographer every year. We build a very nice program. The first part of it is theoretical lectures, and then we take them to the desert. We lay out telescopes, we lay out cameras, tripods, all the equipment you have in mind, and we usually have, like, people have, you know, really good time in these astrophotography workshops, and we get more than 100 people every single time. And here I'm just showing you random images, shots taken from these workshops. People are, you know, they get connected, they meet, and they, you know, they form new relationships. We also have our own spaced out podcast discussing different astronomical topics. We invite one speaker. You know, we publish one episode every week. We prepare for this also. We have really cool special speakers or guest speakers every time. Barry Barish, Farul Baz, Shal Ashid, Shil Tartar, maybe you know some of them. So we try to diverse our guest speakers in terms of the topics. We also have developed our own track for this podcast. So this is also a continuous thing. Our social media, we have been on social media not for so long, actually, less than a year, with the help of Fahad and Bianca especially. If you go and follow our social media, cas.nyuad on TikTok or on Instagram, you would see millions of views on these videos that we post. They're really short, they're really visually nice, they have the music effect, and we're getting a lot of views. Like, I don't want to say we are surprised, but we are a bit surprised, I have to say. Yeah, so this is also part of our these are a group of our researchers, the kind of content we post. Finally, this is something that we've worked on for more than 2 years, I want to say. It's a graphic novel. We worked on it along with two creative writers, Fred and Solistus. And so it was a group of 4 people, including Bianca and these people and myself and Andrea. And I don't want to talk a lot about it, but I brought two copies of these. I'm going to give them away for those who are interested in comic books. But just to very briefly, the story is about, here his name is Nova. Nova is a bright star. Actually, is a young blue star, learning how to shine, how to fuse hydrogen to helium. Okay, and then this is her. This is the mother of Noah. Okay, she's his teacher, and then he goes to the Lunar Academy, so where they teach him how to fuse. It's really scientific, but it's also a graphic novel. And then some bad things happen in the story. Some bad guys appear in the story. I don't know if you wanna think about the bad guys, but if you think of the HR diagram, the evolution of stars, I would say the bad guys are really the white dwarfs, because sometimes the white dwarfs come to main sequence stars, absorb their gases, you know, and then they can live again. So it's a really interesting story. We worked 2 years on it. We did a very nice launching in the book festival. This is Bianca, if you haven't met her or seen her. These are the 2 writers, and this is Andrea. So we keep ourselves busy in the center. This is also the group from the launch of our book. That was actually the launch less than 1 year ago. So this is also us giving one of the first books to the UAE astronaut in this picture. So there's a lot of things going on. I wanted to share this. Maybe these are things you wanna do in your group, in your institute, in your school, or maybe you wanna propose something to us to add it to our program. And last but not least, if anyone is interested, yes, okay, I see 2 hands. I'll just give them to you. Sorry. Okay, and thank you so much.
Thank you. Any questions? Yeah.
I want to ask you about the uh, language you use, just Arabic or English, because I know internationals. There are a lot of international person who live in Abu Dhabi, Dubai, and
We rarely use Arabic. It's actually
okay.
most of the people are speaking
Sorry. Great talk. 2 questions. One, sort of what is driving this outreach, since you said it is a research center? And the related question to that is, where does your funding come from?
Good question. So where does this come from? Like, where does this outreach come from? I think it started with Andrea, who's the director of the center. He was interested in outreach. And then he met Bianca, and then he met me, and they were like, okay, we can work together and make this outreach program. We started the outreach program, I would say, 4 or 5 years ago. So it was just a collaborative efforts from different members, and this is how it went. And we really liked what we are doing in here. So where does the funding come from? Just like any other center, usually science centers, their fundings come from different governmental entities. The same thing happens with us. So we have to renew every several years. And because they have seen the impact we've done with the outreach, we've actually been given a dedicated fund from the funding agency, which is governmental related, of course.
And I guess just to clarify, because like in the US, when we have grants, there's a broader impacts component of our funding. Is there an equivalent for your researchers?
Yes, actually, yes, there is. I don't think it is as scientific as the one you would probably use in the US, but we do try to get all the statistics, all the numbers, all the attendees, how much we impacted. I don't know what metric you use, but definitely this would be included in our reports every 2 years mainly. Thank you.
Okay, thanks to the speaker again. So just a note that, 2 notes actually. One is we asked the speakers to kindly stay always behind the desk, otherwise the online people don't see the who's talking. And also they asked me if Talia Mohammadi is in the room. No? Okay, so he won't present today because the slides were not uploaded. So I guess we're gonna skip that talk. Okay, so we welcome here the next speaker, Seyed Mohammad Hossein Mirhashemi. Oh, okay. It was in person here. Okay.
Okay, hello. Great, thank you so much. Hello, everyone. Ladies and gentlemen, my name is Mohammad Hossein Mirhashemi from University of Tehran. Today, I will talk about Diverging, Discourses of Science Communication in Iran. This field is my favorite field of study as I'm doing my thesis on science communication, especially discourses of science communication in different countries, including Iran and the Middle Eastern countries. And my main argument in this research is that what we know as media shift in science communication is not all the thing that we know. We have change in the meaning attached to science communications, especially astronomy outreach, which is the headline of this research. And if we want to consider what we have had in Iran during the decades ago, as my colleagues in this conference talked about it, about the 20 to 30 years ago, television played a central role in popularizing astronomy in Iran, and especially state media. State media once played a central role, for example, by broadcasting programs like Asman Shab or the Night Sky, which was so popular and was so influential in Iranian science communication community and between the public. And but when we consider the trend of these programs, we will notice a change. And this change is what I want to address in this research. When social media emerged in Iran, they by and by became a place where all the science communicators from different fields of science, especially astronomy, get together in order to organize events, in order to communicate astronomy to the people. And on the other hand, the way and the astronomy outreach, the astronomy communication heavily declined. What we can say about what has happened here is that a hypothesis of my research. I believe that we have two main discourse in science communication in Iran, which has a diverging route in the way they're achieving on the meaning of science. And in the what I have as the research question of my research, I can say that astronomy outreach is completely different, completely different framed in these two media discourses, in these two science communication discourses. And when you consider science communications in these two discourses, you will be able to understand this, that values that are attached to science is completely different. And every discourse that I have studied in this research have chosen a different way in order to portray astronomy and astronomy outreach, and about what is the importance of astronomy in the society. I conducted research with 10 science communicators inside Iran. It was about the and in some cases, as one of science communicators, I chose the science communicators from two blocks of the discourse of science communication in Iran. Some of them were podcasters, the other was active in outreach of astronomy, and some others were in state media and some news agency inside Iran. What was really interesting to me is that I recognize two major discourses of science communication. And each one of them define the way they look astronomy. State media discourse mainly science science itself as a look as an hour. And when the people deal with this media, try to, for example, different astronomy or space science or space science. It was about what is an honor for the country, what was the related to the power of the country. For example, the subjects like domestic satellite achievements was of high importance for these interviewees. And in this in interviews I had, space topics are covered with mostly in fact, rocket science and satellite science. On the other hand, we have people from social media and civil society, astronomy outreach activities, and some science communicators. In this area, I encountered people which consider the main reason behind their activities as wonder, curiosity, and public participation, and to talk about astronomy as the pillar of science, as the parallel way of cognition, as the in some areas. Even I encountered people which consider the science itself as a secular horizon to understand the world. So it was a parallel kind of cognition. And the thing which was so interesting to me is that they didn't limit the way that they're doing this communication by broadcasting. They liked podcasts. They liked, for example, observatory and making community around astronomy. And it was heavily different with what we had in the first discourse. If we want to summarize these two different discourses, I can say that the first discourse sees science as power, achievement, and technology. In this way of looking, astronomy is not much important because you are not, for example, curiosity, engagement, wonder, and understanding the world in a different way. In fact, outreach of astronomy played a central role in their science communication. And if you look at what is going on in as science communication in social media, Iranian social media, for example, on Instagram, YouTube, or Telegram, you see that astronomy and astronomy outreach is play a central role in all the activities that science communicators are doing. And when we consider these two different discourses, we find out that these two discourses are in fact separating more and more. I mean, if you look at, for example, state media or news agencies in Iran, for example, 20 years ago, astronomy has a much more important role in comparison to today. Today, technology and, for example, some biotechnologies, space technologies related are much more important. And the main findings of this research that I can tell you is that these two major discourses of science communication in Iran are being increasingly diverged. As I told, the state media as a representative of the first discourse that I considered in this research frames science mainly as technology related to technology. When you are talking about the science that is not directly related to technology, it isn't of a higher value. National achievement and instrumental power. On the other hand, the discourse that is related to social media and civil society of Iran, considering science as a way through which you can promote and public cognition, a parallel public cognition, which is different from, for example, former or established way of cognition. And public engagement literally is so important in this discourse. And the other thing is that unlike the first discourse, is heavily related to Israel.
Hi, Mohammad.
Yes.
It's time, no? You can finish, no?
Yes, sure. And this is the last slide I want to talk about. Yes. And in the discussion slide, I want to pay attention to the decline of astronomy in one of this discourse and highlighting it in the other one. And the last thing that I want to say is that in fact, we do not have transformation in the media. We have kind of transformation in the meaning that attached to the and
Yeah, unfortunately, the connection was not good. Is there any questions in the room?
Hello, I'm Seyed Jafari. You talked about the discourse analysis because I have a background in linguistics and we studied this discourse analysis. How did you actually examine your data? Because discourse based on the spoken and the written language, you mean actually research on the Persian. So this is something that you mentioned. You actually research on 10 science communicator in Tehran. So this is give you the exact result about the discourse analysis, because this field is really hard and the data, it depends on any researcher, you know, are different as it's qualitative research method. It's not the quantity.
I interviewed science communicators from across Iran. I think 4 of them were from Tehran, 1 from Isfahan, 1 from Shiraz, and 1 from Tabriz. And it was so important to me that I chose different people from different organizations and different media or entities. What my research as a methodology is focusing on is discourse analysis. And for example, Fairclough or some other discourse analysis are the way that I using them in order to analyze my data.
Thanks to the speaker again. And we go to the next speaker, Mohammad Sadegh Faghanpour. Okay, sorry. Okay, so you will present together? Okay. The talk is about naming stars and multicultural enterprise for outreach and education, for use in outreach and education. Okay.
How to switch the slides. Okay, so let's do it the old-fashioned way. We are representing the working group on star names of the IAU. We, that is Mohammad, Sadegh, Faghanpour, who will speak after me, and myself as the chair, and he as the social media agent of this group. Next slide, please. We, in the IAU, consider the night sky as a shared human heritage. So the IAU wants to represent as many as possible of the cultures of the world. Next slide, please. In star names, because constellations are named already. Next slide. So we want to use the many stars that are unnamed to represent the cultures. Unfortunately, all the cultures have named a few, like 50 bright stars, but almost no culture has named the faint stars. So what do? We cannot, the IAU needs one name per star and not more than one. We need an unambiguous nomenclature in international global language, science language. And we are making the names actually for the use in astrophysics. So we actually also parallelly encourage everybody to use their own cultural names in planetarium shows and of course education on all levels in school and beyond school. But the names that the IAU makes should be used in astrophysics and then represent this culture from which the culture of our origin for the name internationally. Next slide, please. And so there are some star names already that are in common use, like Betelgeuse, Vega, and so on, and they are typically they typically originate from one of the languages here in that area and west of it, like West Asia and East Europe. And next slide, please. And we are currently trying to diversify this realm of languages. The Chinese are currently very active in proposing names because they also have a longer than the Greek tradition of written history of astronomy. So we can draw a lot of material from the Chinese culture. Next slide, please. The Arabic is, of course, very strong because of the history of the last 1,000 years in common use. But we also continue adopting new Arabic names, but we also want to have other names from other languages. And you can see here that in the first decade of the existence of the working group, next slide, please, the distribution was really became much bigger and way beyond all the ancient languages. Because there were the naming campaigns, name ExoWorld campaigns in 2015, 19, and 22. And here you see a world map, and the colors, of course you cannot read that, but the colors of these labels indicate the languages per continent. And you see that due to the naming campaign, due to the public outreach of the IAU, actually we have now in our IAU name catalog for stars, all continents represented, not equally, but we have names from Australia, from Asia, from Africa, and from both Americas. Next slide. And next slide. And we continue, next, please. We continue diversifying these the names by collating the material from all sorts of studies in the humanities in All Skies Encyclopedia. Next slide, please. Which is one of the resources that we are setting up. So this is an encyclopedia where the members of the working group enter their research, and we will have a huge repository of names that in principle are out there. That doesn't necessarily mean that they are adopted in the name catalog, but they are the heritage of this specific name, might that be a name of a constellation or a star, is preserved. Next slide. We also built some material for people, for teachers and educators to use in outreach. Just last week, we got a message, an email from an Italian primary school teacher who successfully uses our material on our website, Exoplanet, exoplat.net. Next slide, please. And you can see here clearly that in the first period of the first phase of WGSN, we had the naming campaigns and this outburst of names from everywhere, which don't have anything to do with the sky, like the terms "thank you" in any African language now is a star name, and then there was a gap because people discovered that we want to preserve the heritage of cultures. There are actual cultures out there with a lot of heritage that we can preserve in the sky. And then we started a new working mode. And with that, next slide, please. We are still operating, and we want to operate for the next years. Next slide, please. This and the next slide present the outcome of the last 2 years of very intense research in many philologies and history and ethnology, ethnoastronomy. And you see still the names spread all over the sky. So the northern and southern hemisphere are both covered. Next slide, please. And the procedure, next slide, please. Then the procedure for adopting names now becomes more formal, we have guidelines since last year. So first, a lot of research to be done or collated, then collected in the encyclopedia, so structured and so on after according to specific given headlines, so that we have all information like on mythology, on religious purpose, on cultural background, on etymology and so on for each and every name that we input into. And then if the culture of origin of this term, of the constellation name or star name, allows the IAU to use it on the global scale, then we ask this indigenous group to propose the name to the working group as an official star name. We cross-check it with our guidelines and then adopt the name, typically. Next slide, please. And with that, then the outreach continues, and that is why I hand over to my colleague, because you make this wonderful info cards for each and every star name. You have to come here if you want to get the microphone.
Hello, everyone. My name is Mohammad Sadegh Faghanpour, and WGSN outreach approach from research to public engagement. Our profile card is our production of WGS, and you can see that's have 2 parts. The one part includes astrophysical characters and etymological, and the second part is the location of the stars in the constellation. This profile card includes astrophysical data, cultural background, and constellation context, designed for the student, educator, and general public. Next slide. And the last thing I say about that, the AI help us for created as a visualization of the stars. You can see we put the astrophysical data to AI, for example, Gemini, in this for Betelgeuse star, and you see the visualization and AI generation of Betelgeuse, and this is the real image observation of Betelgeuse. And the next, this slide summarizes AI's role in our project. AI help us quickly and consistently create visual context. AI transfer astrophysical description into visual representation of a star, fast and consistent content generation, and used as base for outreach cards, and limitation, no AI for text generation. Only humans in sprint meaning. And you can see in the future, we want to create a booklet of WGS and profile cards, all of a star named by WGS and working group on star names. And the next,
So yeah, so with that we started an outreach program actually, and we hope to bridge the gaps between science and humanities, because on one of the info cards we have the etymology, the historical background, as well as the astrophysics of the star, and we also want to increase the public awareness of this. Well, of the global heritage that we share in the sky, so that you know, star names from South America can also be used in planetariums in China and vice versa and so on. So with that, thank you very much, and we are taking questions.
Oh, okay, thank you very much. Okay, one question.
So I seem to remember for name exo worlds that the stars that were associated with each country were visible from the place where the name originated. And is that also true for all of these names?
Generally, yes, because the culture, the name originates from the culture. So then when an ancient Chinese astronomer named a star, then the star must have been visible in ancient China. So there might be some cases of precession where you know, the star shifted a little bit, but I think we can neglect that due to the expansions of ancient, well, not only empires, like all sorts of entities. So in general, due to the fact that the name is historical and had been used or has been used ever since in that region, well, most likely the star will be visible in that country. We currently don't deal with faint stars, generally speaking, because we want to preserve the heritage of people, and it would be unfair to, you know, use a very faint star for a very important, like the Chinese yellow emperor figure, mythological figure that is very important for the culture, and to attach that name in Chinese to any 8 magnitude star, that would not be appropriate for the huge significance of the historical name in that culture. This was
Two more questions.
Thank you. Do you think how good of a match you have with the traditional star varieties and the name, or do you take an arbitrary road?
No, we don't take an arbitrary road, definitely. I'm a little bit hesitant to give a specific number or anything. So, you know, there are written cultures with a long written tradition, like the Europeans or West Asians or East Asians, where we have like 3,000 years of history, and we know exactly, or well, we know very well where a specific name was attached, and that the name maybe was shifted. Like in one culture, one epoch, it was attached to this star, and later it was moved to another star. And then we would choose one of them for good reasons, but yeah, still that might be well, not completely random, but like for instance, our Chinese members prefer the brighter stars in these cases where it's ambiguous. Then there are other cultures, most indigenous, who don't have a written tradition. So where all the knowledge is interview-based, and then researchers go to different families and get different answers where the name has to be. Like this, there is this name XY, and somebody attaches it to the Scorpion and the other person to Orion, which is really opposite side of the sky, right? So in these cases, well, it depends on we really encourage the indigenous groups to tell us where they want us to put the name. We have these cases currently in Indonesia, and although there might be some historical research like 150 years ago, we then prefer what the local priests today want us to, the area or the star that they want us to use.
Thank you.
I want to know how does it work inside IAU for naming minor planets, meteorites. I don't know everything, such as exoplanets, naming stars. Are you cooperate with each other? Is there any structure for that? Because every day we have some new exoplanet with this name, with minor planets, and everybody say, I'm the owner. I want to know how it works.
Well, there's an international space treaty, so nobody owns exoplanets or anything beyond the moon. Well, from the moon on beyond. But anyway, so the naming strategy, the nomenclature, the IAU is by international agreement in charge of naming of the nomenclature of everything in the sky. Which means if you want to name a lunar crater, then you have to find the IAU working group which deals with the lunar crater. If you want to name an asteroid, then you have to be the discoverer of the asteroid. And then you are allowed to propose the name. For the comets, the comet gets the name of the discoverer. There's no debate, no discussion. And there, for each and every category of objects, there are different rules. And for the working groups, there are three, I think, currently, working groups, nomenclature working groups, 3 or 4 in the IAU, like for asteroids, for, well, small bodies of the solar system, generally speaking, for structures, surface structures in the solar system, like mountains on Mars and so on, and of our star name group. And there's also, there is this group for exoplanets, which is rather inactive currently, but it exists. And they all have different rules, and like asteroid naming has a 200 years tradition. As we, as a working group of star names, are only 10 years old. So, well, yes, there is a framework. There's no like day-to-day base collaboration. But we want to, I mean, we all have the goal of the unambiguous nomenclature. So if the IAU working group on star names wants to name a star, of course, we check if there is an asteroid with this name. If so, then we cannot use the name, and vice versa. And that is why the probable next step will be to have all the asteroid names also included in the encyclopedia. Currently, we are working with lists to exchange that, which is not very convenient. But the encyclopedia project is only 2 years old, and there's only one person who administrates it, which means as human lifetime is limited, it's not yet done, but that will be the next step. We already started the discussions.
Okay, thanks to the speakers again. So unfortunately, we're skipping the next talk, and we go to the last one, which is a recorded video. They tell me that Maryam actually is connected on Ring Central, so we won't be able to ask questions after. She won't reply by voice, but you can write her on Ring Central. So we can go on with the video now.
Hello everyone, I am Maryam Papari from Mir Observatory in southern Iran and IAOA night for Iran. Today I would like to share some of our experiences in astronomy education and public engagement in underserved regions of southern Iran through observational, educational, and cultural activities. Our work mainly focuses on making astronomy more accessible to different communities, especially students, teachers, women, and people living in remote areas. Southern Iran includes many small towns and rural communities where access to astronomy education and scientific facilities is limited. In many schools, students do not have access to telescopes, astronomy workshops, or trained astronomy educators. In some remote areas, many students have never had the opportunity to participate in a scientific observing activity or even look through a telescope. At the same time, interest in astronomy among young people has been growing significantly in recent years. Social media, astronomical events, and public interest in space science have increased curiosity about the universe. Because of the growing interest, Mir Observatory has tried to create educational programs that are accessible, practical, and inclusive. Our goal has been not only to teach astronomy, but also to create a connection between science, culture, and daily life. Over the past several years, Mirha Observatory has organized many astronomy education and public outreach activities across southern Iran. These programs include teacher training workshops, public observing nights, astronomy camps, online educational programs, and outreach activities using portable planetarium, solar telescopes, and etc. One of the important parts of our activities has been organized NASA workshops. In these workshops, participants learn astronomy through hands-on activities and simple experiments. They also build educational instruments using inexpensive materials, which makes astronomy education more accessible for schools with limited resources. We have conducted programs both in person and online. While face-to-face interaction has always been our priority, online activities allowed us to reach participants from distant provinces, underserved regions, especially during the COVID-19 period. The portable planetarium has also played an important role in our outreach activities. For many children in remote communities, entering the portable planetarium was their first experience of learning astronomy in an interactive environment. These experiences help the students see astronomy not only as a school subject, but as something exciting, creative, and connected to their lives. One of the most important aspects of our outreach activities has been connecting astronomy with Iranian culture heritage. Many traditional Iranian celebrations are closely connected to astronomical events and seasonal changes. For example, Nowruz is associated with the March equinox, Yalda night is connected to the winter solstice, and celebrations such as Tirgan and Mehrgan are related to seasonal cycles and the traditional Iranian calendar. By connecting astronomy with cultural traditions, people often feel a stronger emotional and personal connection to science. This approach is especially useful in public outreach because culture creates a familiar pathway for introducing scientific concepts. Instead of presenting astronomy as something distant or highly technical, we present it as something already connected to people's traditions, history, and identity. In addition to public celebrations, we also discuss the historical relationship between astronomy and Iranian civilization. During our programs, we introduce participants to the scientific contributions of Persian scholars such as Omar Khayyam, who played an important role in calendar studies and astronomy. We also discuss historical astronomical structures such as Chardaqi, which some of them are connected to ancient observational traditions in Iran. These discussions help participants understand that astronomy has deep historical roots in Iranian culture, and that scientific curiosity has always been part of our heritage. For many young participants, this creates a sense of pride and a strong connection with science. One of the important goals of Mirha Observatory has been encouraging the participation of women and girls in astronomy education. In some underserved regions, girls may have fewer opportunities to participate in extracurricular scientific activities because of educational or social limitations. For this reason, we have tried to create supportive and inclusive educational environments where girls can actively participate in workshops, observing sessions, and public events. Over time, many girls who first joined as participants became active members of astronomy clubs and educational programs. Hello everyone, I am Maryam Papari from Observational Scientific contributions of Persian scholars such as Omar Khayyam, who played an important role in calendar studies in astronomy. We also discuss historical astronomical structures such as Sadegh, which some of them are connected to ancient observational traditions in Iran. These discussions helps participants understand that astronomy has deep historical roots in Iranian culture and that scientific curiosity has always been part of our heritage. For many young participants, this creates a sense of pride and a strong connection with science. One of the important goals of Mir Observatory has been encouraging the participation of women and girls in astronomy education. In some underserved regions, girls may have fewer opportunities to participate in extracurricular scientific activities because of educational or social limitations. For this reason, we have tried to create supportive and inclusive educational environments where girls can actively participate in workshops, observing sessions, and public events. Over time, many girls who first joined as participants became active members of astronomy clubs and
Okay, so the online chair says that Maryam is connected to Ring Central. So, sorry.
If anyone asks the question, I can answer.
Okay, okay, okay. So if there is any questions here in the room. Questions? Let me see if there is questions online. So there is a question online for Mohammad Hossein Mirhashemi. Yeah. It's a question that they didn't see before. So if it's okay here. The question is how social media changed the way participants attend in the program.
Okay, do you hear me? The question that I had from Mr. Kookaram. I think now I must. I have a question from Mr. Kazem Kookaram. His activities spanned from the time before emerge of social media in Iran, and then when social media appeared, many outreach activities, including what we have in astronomy, is organized in social media. I just want to ask, what difference do you see in the organization of your outreach activities, especially what you have presented in your presentation?
Hello, Mr. Mirhashemi. Thank you for your question. I think that in recent years, the activity in Iran is very differentiated with the last because of the sanctions, because of the economic situation that we have in Iran. All of them are restricted. All of them are going to small and I don't know that did you my presentation or not. Everything in recent years is going to be limited, unfortunately, and I hope to go into better situation in soon in near future.
Thank you.
Okay, so I think that's all. It's this is of course a very ambitious and challenging setup. So there were some issues, but thanks to all the speakers for the contributions, and we finished just in time. So now there's the coffee break. Thank you again to everybody.